Welcome back everyone. Now we're going to learn about the decoders. So what are the decoders? Actually, I missed the S here, so let's write the S. And now it's the decoders. For the simplest of the thing, let me show you a diagram, then we can proceed on that basis. So I'm drawing something here. You can focus upon that. I'm drawing a, let's say, 3 cross 8 decoder, and this is the IC presentation for this, or indicate circuit presentation for it. So this is IC presentation of the decoders. Okay, of decoders. So we surely need some input and output things, so I'm drawing the input and output thing. Like I wrote the three, that means I'm giving the three inputs here. First one is always gone for the input, like let's say X, Y and Z are the outputs here, sorry, inputs here. And now it's time for the output, so I have to draw the 8 outputs: 1 2 3 4 5 6 7 8. And on the base of the numbering, we can start with the 0, as in all the things we start with the 0 thing, D0, D1, D2 and all the way up to D7. And these are the 8 inputs. So 3 inputs we have and 8 outputs. I hope I made my point clear here, that we have input and input here. So this is kind of the decoder that we use. So what we do understand with the decoders, let's leave this for a moment and let's think that what is a decoder. Like I have a secret message and you need to decode it. Yes, it's incorrect in English spelling, and if I write something, you can decode it and you can easily understand that I meant with this the secret, secret and message. So you can make the complete information out of it. So what you just did is called as decoding. So you just decoded a message, and that is the meaning of the decoding. Like if I write 1 2 and 4, and I give you some information on which basis you know that 1 represents A, 2 represents B and 4 represents D. So the message is A B D. So this is kind of the simple decoding that I taught you here. So this is exactly what's happening in the machine also, like in here that we have seen. So that's what the meaning of the decoding. And let's write few lines so that we can understand this even more clearer. So let me write the definition so that you can read along the side that what is the meaning of the decoders. So and the decoders we have right here, it is a combination circuit. As we all know that we are studying the combination circuit that converts binary information from n input lines. Well, in our case it was 3, of a maximum 2 to the power n unique output lines. Well, you can ponder that why the maximum is 2 to the power n, that we're going to see in just a while. So okay, that's all it for the definition part. I think we can understand everything from this one also itself. Okay, so in our case we were having X, Y and Z as the 3 inputs or input lines, and the 7 output lines, like D0 to all the way to D7. So here we are seeing that 2 to the power 3 can maximum output lines. So can you guess why it's so? Well, if you guessed it, I'm proud of you, my dear friend, because it's very easy that what the input you can give actually. You can give 0 or 1, 0 or 1, 0 or 1. So there's two combination, two combination, two combination. If you multiply them all, so you get 2 to the power 3. That's what we meant with this. Like if you have n input, so 2 to the power n. That's simple. That is the maximum possible combination that we can have. So that's what we are doing here. So this is exactly the meaning of the decoding, that we can decode on the base of the zeros and one. That's the binary part that we have written right here. And as per this binary part, now we understood the meaning of the decoders. Okay, so let me present you with the truth table of the 3-bit binary to decimal decoder. Let's make a TD into table of 3-bit binary to decimal decoder. So we are trying to make something which is having 3 bits binary, and we are going to decode it in the base of the decimal. Okay, let's study this. So let's have a serial number here that will help us to understand few of the things. And now we have something, let's say input type. I will write the output thing in just a while. Okay, let's start making the table and learn along the way. That will be a lot better, in my opinion. Okay, so let's make something out of it. So here we have 0, 1, 2, 3, 4, 5, 6, 7. So I'm taking the 8 serial number, so something has to do with the 8. Well, that's the 3-bit. Yes, you guessed it right. For the 4-bit, we can go along like 2 to the power 4, that will be 16. Now, in this case, in our case, we have 3-bit means 2 to the power 3, which is 8. So 0 to 7 is 8. So absolutely correct, my dear friend. You have guessed it. You are getting smarter. I'm proud of you. Okay, so now it's time for us to present some inputs, like we have X input, Y input and Z input. So let's make our inputs clear first. So first of all, we have 0, 0, 0, then 0, 0, 1, then 0, 1, 0, then 0, 1, 1, then 1, 0, 0, then 1, 0, 1, finally 1, 1, 0, and at last 1, 1, 1. I guess I have wrote the 7. Let's check it. 1, 2, 3, 4, 5, 6, 7, 8. Yes, these are the 8 inputs that we have here. Okay, now it's time to have the, okay, I wrote the input here, but I actually made the input right there. So I'm removing this one and writing the input right here. So these are the inputs that we have provided, and now it's time for the output that we have. So the possible output that we have is already known to you right now. So what we're gonna do is D0, D1, D2, D3, and D4, D5, D6, and finally we have D7. So this is all the thing in the output, and if we make one more line and allow ourselves to study and stretch a little more into the topic, so we can have one more term which can be called as min term or minimum term. So let's write the min term also, and as I'm going to write it, you're gonna learn that what and why actually I have wrote that thing. Okay, so let's use a white color for this. So we have x dash y dash z dash and x dash y dash z. I hope you are getting the pattern. I am just writing it so that you can get the pattern, right? And here we have z dash, and the fourth one we have x dash y z, and then the fifth one we have x y dash z dash, and then we have x y dash z, and then x y z dash, and then finally x y z. Yes, you have said correctly. The bar thing or the complement, whatever we like to call it, is representing the zero, like x to the power. This one is zero, and when we write x is one, and same for the y and z or z, you can say. So that's all the thing that we have learned to represent. Well, why I presented you with this one? Like we don't need that actually studying in the form, but I'm telling you this and making this table before so that we can understand its logic, and by using that logic we are going to design a circuit. Yes, you have heard me right. Now we're going to design a circuit, so let's design our circuit first, and then we'll talk about the further thing. So first of all, we need 8 AND gates that I'm adding up here. So let me make the AND gates first, and you can do the same thing with me and enjoy the song that I can go on with. This one's 1, 2, 3, 4, 5, 6, 7, and finally we have 8. So these are the AND gates, and don't get confused if my drawing is a little bit of not so much like the AND gate that we have studied. It actually is made in this way, but all the time when you draw it, sometime it messes up, so don't worry about that. You just have to understand that it's the AND gate, that's it, nothing else is required. Okay, let's name this thing. This is called as D0, D1, D2, D3, D4, D5, D6, and finally we have D7. Now in just a moment you will recognize that why we made this table first, and then we can design the circuit as whichever way we wish to. Well, let me write the thing. Like I am expecting here to get the input x dash y z dash, all the dashes, and in the second one x dash y dash z, in the for the next x dash y z dash, and in the D3 one I am expecting x dash y z. Well, you can do it just like me and go on writing with that. If you have any problem in recognizing how I'm writing it, so you can just go on with the table. That's why I have written the min term here, otherwise it is not required. That's why I represent the min term so that you can recognize this thing. And if you are trying to follow the shortcut just like me, just remember that 1 and 0's thing, and just write xyz everywhere, and just remember that which one is 0 and put the complement over it. That's it, that's all what it takes. So now we are done with this. Okay, now we need to make the NOT gates also, so that we can complete the things. So let's make the NOT gate here. This is the NOT gate, this is the NOT gate, and this is the NOT gate. Well, in the NOT gate we also add the small circle here. And can you recognize that why I am adding just 3 NOT gates? Well, that's quite pretty much interesting thing, that why only 3, not 4, not 1, why 3? Well, that's interesting thing. Keep wondering about that one, and I'm gonna answer that just in a while, and we're gonna see that thing. Okay, so well, I suggest you something that if you ever want to design the circuit, learn some drawing first, otherwise you will draw the lines just like me. Okay, well, just kidding. Uh, anyway, it sometimes get difficult to make the lines properly. Well, I hope I have made it clear on this basis. Yeah. Now, the answer of the question is that why we are using just three AND gates, like what we are giving as the input. X, Y, and Z, right? And all the things that we require is Y, Z, and Z dash. So just we need three NOT gates to invert the X, Y, Z logics. That's all the thing that we need to do here. Okay, now let's make the connections. And for the connection of first one, we can see it's X dash, Y dash, and Z dash. So all the dashes must be covered up for the first one, and you can make something like this. Well, actually there are three inputs, so I cannot technically make it like this way. I have to do it a little bit of spacey thing type thing, and then I can put these things in here. Like there are three inputs, so I cannot make it in just one. That's the reason. So in this one we have the Z, and X dash Y dash is coming from these ways that we have here, right here. And just recognize these things, and we just got these. And now in the third one we have Y as the thing, so just Y is marked up, and we have here. And for the rest of the thing we need the dashes, so Z dash is attached here, and X dash, so we are taking the input line here. Well, this is one of the easiest way to do so. Like in here you can see that we make these lines first. So these are the wires that we just extend and we connect with all the things. Otherwise we need to make so much NOT gates, or each separately NOT gate. That will be not practical or very much obvious thing. It will be a difficult thing to make, so we do it in this way. Like if you're drawing that in a bigger paper, so you can draw it a quite good way, not messy like me sometimes. Well, sometimes I intentionally mess it up. You know why? Well, you can keep ponder upon that. Well, I do sometimes mess up with the thing so that we can learn more detailed thing, because when it's not so clear and you are trying to focus it up, you focus more, you ask more question, and that's one of the way I use in my teaching. Well, not always, but sometimes it's recognizable. I'm trying to make it clear, but sometimes not clear is also intentional. So you cannot just find the difference when I am tricking you and when I'm actually getting messed up with my drawing sometimes. So now we are left with the two connections only. So x1 and y1, and for the z dash, so we're gonna make it here. So we are having these here. Well, you can ponder that. I can even tell you by doing one or two, and I can just run the video faster or skip this step and not talk to you and just show you the circuit. But I don't want to do that. The reason for that is that I am doing it right in front of you, that when you are going to do it, it will take time and it takes the practice. So to understand the value of the practice, I am doing every single connection right in front of you, so that you can understand that even if it takes time, give it some time. Even after this much of the practice and the experience as a teacher, I even take time. So if you take time to learn, that is completely okay. So that's why I'm doing it slowly and doing it with the chatty thing, and then making the connections drawn, so that you can understand, recognize, ask question, and see every of the connection happening. Sometimes it seems boring. Well, it seems boring to me more than anyone, but I'm doing it just because we have to love the subject, and the only way to make a better relationship with our subject, with our teacher, with our student, and all that things is just one way, that we need to give and invest our time, energy, effort, love for the subject. So I'm trying to develop that thing in you. Well, you have made your first decoder, and how it actually works is very simple. Like sometimes this one and this one activates, sometimes this one and this one activates, and sometimes this one and this one activates and this one activates, and give you a kind of the message that you want, and that kind of messages is going to give a definite information. Everything is giving a definite information. That kind of definite information is actually recognizable, and we can understand the entire message of it. So that's it for the decoders one, and we can develop more questions upon that will going to practice in the next one. So till that time, take care, God bless, and keep practicing, my dear friend.